Have you ever been scrolling online and seen one of those math problems that splits the internet in two? Everyone's in the comments, arguing and getting completely different answers from the same exact problem? Well, it almost always boils down to one simple but absolutely critical idea: the order you do things in. Today, we're going to get to the bottom of why that order is so important.
I mean, it just feels wrong, doesn't it? Math is supposed to be certain. So how can one little problem create two totally different results? Well, let's jump right into a story to see exactly how this kind of confusion can happen.
So picture this. We're on a playground with two friends, Malesh and Arun. They brought their marble collections and they just want to figure out how many they have altogether. Sounds easy, right?
Okay, so Malesh has his 30 marbles loose. And Arun, he has his marbles organized. He's got 5 bags, and each one has 4 marbles inside. To get the grand total, Malesh scribbles down an expression, 30 plus 5 times 4.
Now, his friend Purna comes along, takes a look, and goes from left to right. She adds 30 and 5 to get 35, then multiplies by 4 and gets 140. But Malesh does it differently. He multiplies the 5 and 4 first to get 20, then adds the 30 and gets 50. Hold on a second, 140 marbles or 50? They can't both be right. So, who is?
And that right there, that confusion, is exactly why math needs rules. You know, it's kind of like grammar. Without commas and periods, sentences can mean completely different things. Math is the same way. It needs a clear set of rules so that everyone, everywhere, gets the exact same answer.
To start figuring this out, let's step away from the marbles for a second. We're going to look at something we've all done: go shopping and get change back. This is going to show us the first big rule we absolutely need.
So, imagine Irfan's at the store. He's buying a pack of biscuits and some dal, and he hands the cashier a 100 rupee note. Now, if we try to calculate his change by just going left to right, well, you're about to see something pretty wild happen.
He gets back 141 rupees. He'd literally be making money by shopping. That makes zero sense, right? This proves that just charging through a problem from left to right doesn't always work. We need a way to tell the math to group his purchases together first.
And that's where our first hero comes in: brackets. By wrapping the cost of his items in brackets, we're basically shouting at the equation, hey, deal with this part first. Figure out the total cost of the shopping before you do anything else.
So you can think of brackets as a VIP section. You always calculate what's inside them first. The total cost is 71 rupees, and only then do we subtract that from the 100 he paid. And there we go. He gets 29 rupees back. Now that sounds right.
Okay, so brackets are awesome for telling us what to group together. But what about our marble problem? There weren't any brackets there. This is where things get really interesting. We have to learn to see the hidden parts of a math problem. Let's use a drone to visualize this. So, the drone takes off from a terrace. First, it flies up 6 meters. Then, it flies down 4 meters. The expression for its final height is just 6 minus 4. Simple.
But let's look at this differently. Instead of one continuous motion, think of it as two distinct events: a positive movement of 6 and a negative movement of 4. In the language of math, these separate pieces, these building blocks, have a special name. We call them terms.
And here's where we get the big clue. Look at that second row. The plus sign separates the expression into pieces, but notice it doesn't split up the 6 and the 3. Why not? Well, because multiplication and division act like superglue. They stick numbers together so tightly that they become one single unbreakable term. So for that problem, 5 is one term, and that whole 6 times 3 chunk is the second term.
And that's it. That's the secret. Terms are the individual parts of the puzzle, separated by plus or minus signs. And the most important rule of all is this: you have to figure out the value of each individual term first before you even think about adding or subtracting them.
Okay, we've got our new superpower. We understand terms. Let's go back to that playground and finally put this marble mystery to bed. All right, here it is. But now, when you look at it, you're not just seeing a random string of numbers anymore, are you? You can see it structured. You can see the terms.
So let's break it down. The plus sign acts as our separator. That means the first term is just 30. The second term is that superglued block, 5 times 4. So we solve that term first, which gets us 20. And now that we have our simplified terms, we can finally add them up. 30 plus 20 is 50.
And there it is. No confusion, no debate. The one true correct answer is 50 marbles.
Malesh was right all along, because he instinctively understood the hidden structure of the problem.
So, if there's one thing you take away from all this, let it be this simple rule. When you see an expression, find the parts that are stuck together with multiplication or division. Solve those little chunks first to figure out your terms. Then, and only then, can you do all the adding and subtracting.
In the end, that's all this is. Math's version of punctuation. It's there to make sure we're all reading the same sentence and getting the same meaning. After all, you know what happens when you ignore a comma in the sentence? It can change everything. Thanks for joining me on this explainer.